Hello everyone, we're doing piecewise functions today. It's a long lesson with some complicated examples, so I'm going to go kind of quickly. Feel free to pause it when you need to. What is a piecewise function? So let's do an example. Parking lot is a good example. They charge a certain amount depending on how much time you've been there. So you've got $5 for the first hour. Even if you're only there for 2 minutes, you're going to pay $5. And then any amount of time over an hour and up to 2 hours, you're paying $12.50. And then after that, you're paying $13 plus $3 per hour after 2 hours. So there's 3 different pieces to this puzzle here, 3 different pieces of ways of being charged. So how can you describe the function for parking fee? So we want it to be a function because we want to have one input and one output, meaning you pick one time that you're there for. If I'm there for 2.5 hours, there should only be one answer for that, $1. There shouldn't be 2 options. So the first thing we're going to do is determine an equation for the third section, for this section right here. This is the hardest piece. Let x represent the time in hours, since the third portion begins after 2 hours. The domain is x is greater than 2. So what we're about to do only applies for the time after 2 hours or a portion of an hour. The $13 covers the cost of the first 2 hours. So I want you to think about it, press pause, and come up with an equation. You're just writing this on your own piece of paper here. There's no handout for this part. So I want you to come up with an equation that would match the last bullet. And then when you're ready, press play. And I'll show you the answer. So the answer is the cost is equal to 13, that's this 13 here, plus 3 times, we've got to put x minus 2 here. This is kind of the tricky part because you can't, $3 per hour, if I was only there 1 hour, I shouldn't be paying this money. I should be paying this amount, right? This $5. So I need the x minus 2 because the first 2 hours aren't included in this piece of the puzzle. That's why we have x is greater than 2 here, because we won't be subbing in anything more than that. And if I sub in 3, well, you'll see what happens here. So the next step is on your own piece of paper. I want you to take a few minutes to complete a table of values that you think will fully represent the situation from 0 to 5 hours. So you're going to start right up here with 0, and you're going to go through each piece and use these x values right here. Remember your domain, meaning if you're there for 1 hour, which of these pieces are you using? Then we're going to use your table to produce a graph. So I would again like you to press pause. This is supposed to be interactive here. We would be doing this in class. We would be having a lot more interaction. It's hard to do this with a video. So press pause, try to come up with your own table of values, and then on the next slide I will show you what the table of values should be. So here's our table of values, and these are the x values I asked you to use. There should be 5 here. That's okay. So 0, if you're in the parking lot 0 time, you're of course paying $0 if you're not spending any time in there. But even if you're in the parking lot for a quarter of an hour, that's costing you $5. Right? Even if you're not in there the whole hour, you're just in there for a part of an hour. If you're in the parking lot for an hour, you're paying $5. What if you're in there just a little bit over an hour? If you're in there a little bit over an hour, now we're into the second piece. That's going to be $12.50 if you're in there for an hour and a quarter, or an hour, yeah, 1.25 is 1 1/4 hours, an hour and 15 minutes. What if you're in there for 2 hours? So you have to read carefully. 2 hours is also, it says up to and including, so 2 hours is also $12.50. Now we're over 2 hours, 2.5 hours. So 2.5 hours. Now we've got to use our little equation. That's 13 plus 3, and then this 0.5 comes from 2 minus the extra time here, the 2.5 minus 2. So that's $14.50. Using that formula again for 3 hours, we use the formula, we get $16. For 4 hours, we get $19. So hopefully you got this table correct, and if you didn't, just fix it. We're going to plot the points in the table that we got here. We're going to plot these points. Use a solid dot to include a value in an interval. Use an open dot. Let me explain what that means in a second here. So here's our graph. Notice we have some open dots here, here, and here, and we have some solid dots here, here, and here. So the solid dots includes it. So 0, 0 has a solid dot. If you're in the parking lot 0 time, it's $0. That's a solid dot. But right above it, we have an open circle. The solid dot is at 0, 0, and we have an open dot at 0, 5 because we have to indicate that right after, at 1 minute, you're going to pay $5. And it's really hard to find 1 minute on this x-axis scale. So if I'm only in there for 1 minute, really if I'm only in there for 1 minute, I would hope the parking attendant would let me out. But technically, if I'm in there 1 minute, I jump right up to this $5 range. So I'm paying, it's got to be an open circle on the axis because this is a function. Open circle does not include that value. So at 0, 5, we have an open circle. Then we have a closed circle at 1.5 because if you're in there for a full hour, you're paying $5. But then straight above it, we've got an open circle. We've got an open circle here at 112.50 because if you're there for 1 hour, you're paying $5. That's the closed circle. You're not paying $12.50. But if we're in there for 1 hour and 1 minute, which is really hard to graph, we just put an open circle on this above the 1 value here to show we're going really, really close to this 1 value, but we're just to the right of it. Then we've got a closed dot at 212.50, but an open dot right above it because the parking fee at $2 is $12.50, but right above it, we get into the third piece of our piecewise function, into this type here. So the last part of the graph is linear because we have a constant rate of change. We're increasing, we have a slope value there of 3, so we've got a constant rate of change after 2 hours. This is just linear, it just continues on. What is a piecewise function? A piecewise function is defined by using 2 or more rules. So we have 3 different pieces in ours. So the graph is made up of 2 or more pieces of similar different functions. And just to recap a piece of vocabulary, this function is discontinuous because if I was drawing this with my pencil, I would put a dot here, then I'd have to lift my pencil up to go here, draw a straight horizontal line for the $5, lift my pencil up again. So anytime you have to lift your pencil up, it's a discontinuity because it's not flowing completely from 0 to 2. Notice that this is still a function because if I draw a vertical line anywhere, now it looks like there's overlap here, but if I draw a vertical line here and try out the vertical line test, I can see it technically only crosses my function once because of the closed circle and the open circle. So there's no overlap right here. It looks like there might be. Same with over here. We look like we might have overlap. If I draw a vertical line, it's going to cross twice, but it's not actually crossing right here because the graph doesn't exist there. At 1 hour, we have a closed dot. At 1 hour, you're paying $5. You're not also paying $12.50 at 1 hour. So this is still a function. So here's the graph again. To graph a piecewise function, we graph each piece on a restricted domain. A solid dot if the point's included, an open dot otherwise. So that's just a recap of our last slide. Next, we need to create an algebraic representation. So we already came up with the graph. We got a table of values. The table of values brought us to this graph, but now we need an algebraic representation of the piecewise function. That means we need to find an equation for each piece considering restricted domains. If there's an open dot, the point is not included in the domain. So we have 3 pieces, 1, 2, 3. They each need their own equation. So you can press pause here if you want and try to come up with your equations yourself, but I'm going to go ahead and show you the equations. The only thing there's something I'm going to put in after these ifs here. So we'll talk about that in a second. These are actually 4 pieces because I included this dot here in my function. So here's my function. Piecewise always has this big curly bracket. This one I have 4 pieces because of this dot right here. So I've got 4 pieces and they all occur if So I'm going to put in the domains alongside each piece. What is the domain of each function? So let's look at the first one. The first one's pretty straightforward. Our domain for here, f at x will equal 0 only when x is 0. That's the only time we're going to pay no money, if we're not in there at all. We will pay $5 if we're between 0 and 1. This is our, I'm going to circle it up here on the graph. This is our $5 section here. And the domain are the x values. So in this case, when we have a low and a high, we always use this format here. We have x in the middle. We're going to put the low number on the left. The low number is 0. The high number on the right, and the high number is 1. I do have to think about whether or not these are less than or equal to. The portion right here with the closed dot, that means we're including -1. It's got a closed dot, so underneath my lesson symbol here, I have to put equal to. But the other side had an open dot, so I'm not including that. It's an open dot, it's not included. The next piece, the third piece, is $12.50. We paid $12, that's right here, $12.50. We paid $12.50 between these times here, right, between 1 and 2. So I got my x values are between 1 and 2. I just have to think about what we're including here. So we're not including 1, because if we, at 1 hour, we're paying $5. So we're not including 1, it's just less than. But we are including 2. So if you're up to and including 2 hours, so we have to include the 2. We have to put the equal sign underneath here. The last piece is the linear part at the end, and that is going on to infinity every x value that is greater than 2. Not greater than or equal to 2, just greater than 2. So those are the piece domains, the piece domains of the entire function, but altogether there's a domain for the entire function. So we take all these pieces and we put them together, and the domain for the entire function, if you look at the graph, every x value is used. Every x value. So x is an element, because you could be in the parking lot for 1.23687 hours. You could be, so we're talking about real numbers, and all x values are greater than or equal to 0. So that's our domain for the whole function. There's pieces, but the entire function, any value can be an input for x, for time. And I mentioned this before, this is a discontinuous function because there are several breaks in the graph. That is, I think, one more thing here. This example is taken right out of your textbook. So what I'm trying to show you here is how to read your textbook and follow along yourself and do your own examples. So this example, if you open your textbook, or if you're looking at the PDF of the textbook, this is all in there. I just went through it step by step, and it's important that you can do that too, that you can go through your examples yourself that are in the textbook, because I try to keep my videos under an hour. In some cases they're really long, but there's more material that I can't cover in the whole time. Let's do another example here. This one is also going to take some time. Graph the following piecewise function. Look at those pieces there. There are a lot. There are 1, 2, 3, 4 pieces in this function. And they're all this one looks kind of straightforward, but they're all kind of complicated. So when we have a piecewise function, it's important to know what exactly is happening at the endpoints of the domain, because I'm only going to graph this function in between -9 and -4. So I need to know what's going on in between -9 and -4, and that's where this graph is going to go. And this will help me see if it's a continuous function or not. The first piece is a radical function. Recall from grade 11 that the vertex is located at the x value that will result in the square root of 0. So looking at that first function up here, this is the only piece we're doing first. What would you sub in for x that would give you a 0 underneath the radical sign? So the answer to that is 0. If I sub in a 0, so I'll just show my work for the radical over here. I've got negative 3 plus negative root x. If I sub in a 0, I'm going to get negative 3 plus the square root of negative 0, or 0. That will be my vertex, but I'm not allowed to use 0. Look at the domain. The domain is negative 9 is less than x, which is less than negative 4. So my vertex isn't even going to be in the piece that I'm allowed to draw here. So it's nice to know where the vertex is. Very important when you're doing radical functions, but for this one, we're not even going to include it. So I'm going to put it in here. The sub in is 0, we get a negative 3. Okay. The next thing we do need to do, though, is look at the endpoints of the domain. So let's sub in negative 9 and negative 4. So using function notation, f at negative 9, I'm subbing it in here, negative 3 plus negative 9. So that's negative 3 plus the square root of 9, which is negative 3 plus 3. That's a 0. So I have the coordinate here, negative 9, 0. So negative 9, 0 is going to be on my graph. I'm going to go up to my grid right now and I'm going to put it on there. So am I going to put an open circle or a closed circle here at negative 9, 0 when I put it on my graph? Well, according to my domain, it's an open circle. I'm not including negative 9. So negative 9, 0, you're getting an open circle right there. I'm drawing a little bigger than I need to, but that's going to be an open circle. Next, let's try the other endpoint, f at negative 4. So we sub in f at negative 4. So I subbed in negative 4 and we get negative 1. So my next coordinate here is negative 4, negative 1. So I can put that one on. That's within my domain, but notice it's also going to be an open circle. Negative 4, negative 1 is another open circle right there. Now remember I got that point earlier on that I can't use the, let me just highlight it here, this one here, 0, negative 3, I can't use it. I used these two coordinates here. I'm going to use that though just to help me gauge what's going on, because I'll draw this in two different ways here. When those 2 points that I've put on the graph with the open circles, I don't really know if I'm going to connect them with a line going down, because you know what radicals look like, they kind of curve, right? So is my radical function going like that? Or is my radical function curving up the other way? Is it going kind of this way? So I'm not exactly sure, but what's going to tell me that is I'm going to look at that point that I'm not allowed to use, 0, negative 3. 0, negative 3, I see where that would go down there on the y-axis a bit, so I know that my curve is going in this direction here. It's coming down. Whoops. Let's pretend that connected there. All right, there's the first piece done. We've graphed this piece here. Now we're going to try and graph this section. F at x equals negative 1 if x is equal to negative 4. What do you think that means? So we've got, let me write that piece over here. We've got f at x equals negative 1 only when x equals negative 4. So what that really means is f at negative 4 is equal to negative 1. So we just have one point. This is just one point. This is the point negative 4, negative 1. And if you look at our graph, we had negative 4. Look in the bottom right hand corner here. We had negative 4, negative 1 before, but we had an open circle. So now we're being told we need to fill in that circle. So that circle is now, I'm coloring it in green. That circle is now filled in because of the second piece of the piecewise function. So let's take a look at the third piece now. This is a parabola. x squared plus 4x plus 3. And we're going to draw a parabola, but we're only going to put it in between -4 and -1. That's where the parabola exists, only in this section. So to draw a quadratic, if you remember, we need the vertex. So we can either, well, we can complete the square to find the vertex. You could factor it as well. It factors easily. You could factor it and use the zeros. We could sub in the endpoints. The endpoints, as you know, are important, so we could sub those in to get those. But the vertex is really critical. So let's find the vertex. So I'm going to switch to dark red here, and we're going to find the vertex of this piece over here to complete the square. There's no a value, so that makes it easier. I've got x squared plus 4x here, and my 3 stays out. Then the next part of completing the square is finding half of the middle term. So half of 4. So I've got to take my middle term, which is a 4. I've got to take half of that, and then I'm going to square it. So 4 squared, 4 over 2 is 2. 2 squared is 4. So I'm going to add 4, and I'm going to subtract 4. Then I take subtract 4 out so that I have a trinomial. Created a perfect square here. There's my perfect square. To take this -4 out, I have to multiply it by the a value I didn't have. Well, I have an invisible 1 for my a value. So it just stays a -4. Now I've got a perfect square here. This is x plus 2 squared minus 1. If you've forgotten how to complete the square, there is a video, I think, back in the grade 11 review section on how to complete the square. So I've got my vertex. My vertex is at -2, -1. So is that in my domain? Am I allowed to use that point? Here's I'm going to circle or highlight the domain up here. There's my domain. Is my vertex in the domain? Yes, it is. So I get to use this one. So I'm going to put it on. -2, -1 is there. It's a closed circle because it's well within my domain. So I know that this parabola is opening up. I know that it has an a value of 1, which means you could, however you graph your quadratics, you could use a step pattern. You can go ahead and graph it. Let's find out for sure though our endpoint. So I want to know f at -4. I'd like to know where that is exactly. And my other endpoint of my domain is -1. So f at -1, I want to find out where that is exactly. So calculate those. All right, so we've got our values here. We've got -4, 3, and we've got -1, 0. I'm going to put those on my graph, but am I going to put an open circle or a closed circle? So looking back up at our domain for this piece, the -4 is going to be an open circle, but the -1 is going to be a closed circle. So let's put those on the graph. And because this is a function, the question said it was a piecewise function, it makes sense that this open circle, we would have this red open circle here because below it we have a closed circle, and it wouldn't be a function if we didn't have that. So now I'm going to connect my dots. All right, there's our quadratic piece. It looks like a kind of a hook, right? We've still got a function here because open circle right above a closed circle. So we draw a vertical line. This is still passing the vertical line test. And the question said it was a function, so we kind of know in advance it's going to end up being a function. We've got one piece left. The last piece we have is exponential. So this question is a good review for you of all your functions. Exponential. So our last piece, I'll put in the middle here, is f at x equals 2 to the power of x, and that occurs if 0 is less than x, or I like to write the x first, if x is greater than 0. So this is going to tell us everything that's going to happen on the whole right hand side of my graph now. because I'm greater than 0, x values are greater than 0, that's going to have an arrow on the end of it because we're not stopping. So this is a parent function, 2 to the power of x. Hopefully we can graph this one without having to write down a whole explanation. Let's get the endpoint in there for sure. We want to know f at 0. F at 0, 2 to the power of 0. 2 to the power of 0 is 1, so we have a coordinate 0, 1. Is that an open circle or a closed circle? Looking at the domain here, it's just when x is greater than 0, so we're not including 0, so it's got to be an open circle. So we're going to have an open circle on 0, 1. Open circle there. And then from there, if you know your function well enough, you can go ahead and graph it. If not, you can sub in some points or just do it in your head really quickly, right? Sub in a 1, 2 to the power of 1 is 2. Sub in a 2, 2 to the power of 2 is 4. Mouse isn't working. There we go. 2 to the power of 2 is 4. See if we can fit another one on there. 3, 2 to the power of 3 is 8. I can't fit 4 on 2 to the power of 4 is 16. So we're going to connect these. And let's just pretend that crossed there. We put an arrow at the end because this is continuing on for values greater than 0. So that is a complicated piecewise function, but a good one because it's got all different kinds of parts in it you have to look at. And remember over here, I put in this kind of brownish color box continuity. The endpoints are really important. So we had one bit of overlap right here, but then we skipped up here and we skipped a spot here. So this is not a continuous function. Normally I don't do an example here. I would stop, but students have a really hard time with page 52, number 7. So we're going to start it here. We're going to do one sentence at a time. So if you read it, there's a lot of stuff here, right? And the final line is make a piecewise function. So let's just start with the first line. Many income tax systems are calculated using a tiered method, as we do in Canada. It's a tiered method, meaning the income tax you pay is based on how much money you make. It's not the same for everybody as a percentage. The percentages are different. So if you're so a certain tax law, this isn't necessarily Canada, it's just easy for calculations. We got nice round numbers here. The first $100,000 of earnings are subject to a 35% tax. So let's stop there. The first 100% of your earnings. So let's say you make 110%. Well, the first 100% of your earnings, you're going to pay 35% on that. The amount above 100,000 is the second piece, but let's just talk about the first piece. $100,000, first $100,000, you make 35% tax. So how would we represent that with an equation? First piece, the first $100,000 earned. What is the equation just for that first piece? This one's not too hard. It does get harder than this one. This one's pretty straightforward. You're just paying 35%, right? So you're paying 0.35x. If your x is between 0 and $100,000, you're just paying 35%. So that's a pretty straightforward linear piece for the first piece. Okay, now it gets a little more complicated. What about the second piece? Earnings greater than 100,000 and up to 500,000 are subject to a 45% tax. So if you make $110,000, first of all, you're going to pay 35% on the first 100, but then that extra 10,000, you're going to pay 45% on that extra 10,000. This is a little bit like the parking question. So we don't want to pay 45% on everything. That's not the law. The law isn't you're paying 45,000 on your 110,000. You're paying 35% on your first 100,000, and then you're paying 45% on your anything above that, up to and including 500,000. Second piece, earnings greater than 100,000 and up to 500,000. Remember, you also have to pay your first $100,000 that we earned. So you're for sure paying $35,000. You're paying 35% on your first $100,000. That's money for sure gone to the government, $35,000. Now you have to pay your tax on the extra money. So in order not to tax that $100,000 twice, we're already paying $35,000 for that first amount of money. We're going to have to remove that $100,000 from the portion that gets the 45% tax. In other words, if you earned $100,001, you'd pay $35,000 plus 45% on $1. So I want you to press pause here, see if you can come up with an equation for this and then simplify it. So press pause for a second and try to come up with your own equation and I'll show you. So here's the equation that works. Whoops, I have an extra 0 in there that shouldn't be in there. Sorry, that should be, take that out. Sorry, typo right there. Let's just take this off and put it there. There we go. Okay, so we've got 45%. 45%, and then that bracketed part, x minus 100,000, that gets rid of that first $100,000 that I've already paid my tax on. This is for that first $100,000. So I'm going to pay this for sure. This is my 35% on my first piece, right? So I have to pay that, and there's a plus. I have to pay $45,000 on anything over and above $100,000. So you're going to distribute this 0.45 into here, multiply these two together, collect like terms, and then you'll have your second piece. I'm not going to finish the question for you because you still have to do the third piece in your question, but I'm just going to let you work on that for your homework. You have to collect this first, and then you'll have your second piece. So we've done the first piece. We've got most of the second piece done, and then you'll have to do the third piece, which is the people who are making over $500,000. They're getting taxed higher, right? They're getting taxed at 55% just on the money over 500,000. So I'll let you finish that off. Down here we've got your homework, of course, that I would like you to work on. It would be good if you finished number 7 because we already did most of it. If you would like to click on this Piecewise Functions, this takes you to Desmos, and when you get to the Desmos home screen, you'll see, usually they have like a contest or they have staff picks or something like that. Students who have made really amazing, basically graphic art design, but they have to use Piecewise Functions. Otherwise, who's going to win a contest if you just graph a parabola, right? They're using all kinds of functions and they're creating beautiful artwork. So if you go to Desmos, you can find that information there. So there's our lesson on piecewise functions. It's a great lesson to make sure you do lots of questions with because as you saw in our examples, we went through a whole bunch of our functions. We practiced working with a whole bunch of our functions here, and we talked about domain. So that is the end of your lesson. Now, good luck with your homework.